Hi, everybody. Welcome to my third video. Um, Today, we're going to talk about ggplot, specifically ggplot 2, which is both a package and a function. And it's the main way that most people plot things, create visual graphics in R. Um, it's extremely powerful and extremely versatile. Um, I see it used um, all over the place. I've seen it personally used in the New York Times, economist stuff. I think I've seen some Wall Street Journal stuff with it. Like you see it used a lot. And even folks who maybe don't use R for other things, a lot of them will come to R because ggplot2 is just like very powerful. So today we're going to go over some of like the introductory syntax so that you can create some plots yourself. And just as kind of an example of how cool this is, I just want to show you one of my favorite ggplots, which somebody showed me when I was learning all of this, which I just think is wild. Um, this was created in ggplot2. This is Switzerland, where more blue colors denote municipalities with higher income, and more red colors denote higher inequality. So that means purples are both higher income and higher inequality. And it's just stunning in my view. And so you can Google this Timo Grossenbacher, and they actually have all the code and they walk through the whole thing. So I'm sure it's tricky, but it is all available, and it is just showing off like the sheer range of things that you can do with ggplot. So um, this is also going to involve a lot of, we'll see how much we get to today, but this is going to apply a lot of the skills we used last week. Before you plot stuff, you usually have to clean your data, which is always going to involve some set of filtering rows, selecting columns, creating new columns, and summarizing stuff. And so we might do a little bit of that today as we go. So before we get into this, I just want to show you this data set we're going to be using a lot today. Oops. I'm going to load tidyverse. So you'll see that when I load tidyverse, I load ggplot2, which is specifically the plotting package. All the stuff we did last week, just in case you're curious, all the stuff we did last week, select, mutate, filter, summarize, group by, that's all this dplyr package here. Okay. So in tidyverse is a built-in data set called diamonds, which is, I think, really helpful for kind of displaying different ways of plotting stuff. So I did question mark diamonds, and that popped up the help page for the data set. So it contains almost 54,000 rows. Each row is a diamond. And there's 10 different variables, including each diamond's price, carat, cut, color, clarity, and then these like length, width, and depth things as well. And again, it's really helpful for showing off some of the plotting features. So let's start. I'm just going to do one of these here, and then we'll break out what's going on. So our data is going to be diamonds. Let's do, and I forgot something. Okay, so I've made a plot. This is showing each dot is a diamond. And on the x-axis, we have the carat, which I think is like the size, question mark. Oh, weight. Okay, it's a measure of weight. It's the weight of the diamond. And then on the y-axis, on the vertical axis, we have the price of each diamond. And again, each dot's a diamond. So we see, unsurprisingly, heavier diamonds cost more, are more expensive, they're more lucrative, etc. There's also just like some interesting things here that we're going to kind of unpack. You can kind of see, well, a few things. First, you can see that there are these outliers over here on the right-hand side. So these are very heavy diamonds that, in the case of this one, this diamond weighs 5 times as much as this diamond, but is costs the same, which is interesting, right? So there's probably some difference in these diamonds. You can also see, we're going to suss this out more later too, you can also kind of see that there's this interesting grouping here. There's very few diamonds that are 0.95 carat, and a whole lot of diamonds that are a carat of 1. And likewise, you see this grouping at 1.5, and you see, really, I think most clearly, this grouping at 2. There's way, 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 way more diamonds that have a weight of 2 than a weight of like 1.9. And that's probably because, like, when they were cutting these or whatever you do to a diamond, they were specifically going for like specific weights. So again, just like things you can kind of see with these data. Okay, let's go back to the code. There's kind of 3 main things that are going on here. We're specifying the data set we're using. We're telling R how we want to take the variables in our data set and turn them into a visual thing, which is done with this geom point. And the last thing we're doing, I'm going to pull this up here. The last thing we're doing is we are providing specific variables that we're mapping from the diamonds data set to a visual property via this geom. So we're providing a data set, which is diamonds, and then we're telling R what do we want to use from that data set, which variables do we want to use from that data set, and this is kind of telling us how we're using those. So in this case, we're using the diamonds data set. What from that data set are we using? We're using 2 things. We're using the carat variable and we're using the price variable. How are we using those? We're using those in the form of a scatter plot, which is referred to in ggplot as geom_point. So we could think about changing different elements of this, right? So right now we're mapping, or we're plotting the weights of these diamonds against their prices. But we could also look at let's say, the depth compared to the price. So this one's kind of interesting. So most of the diamonds have a depth around here, right? And there's some outliers. But again, just kind of like on a more general level, what did we do? We're still using the diamonds data set, but now we're using different variables from it, but we're still creating a scatter plot. So these 3 parts here, data, that's going to be specified. Well, sorry, let's go one by one. So this first one is going to be specified up here in this main call to ggplot. So ggplot, this one I specifically named which argument this was. So if you look at the ggplot function, you'll see that the first argument is data. The second argument, let's not think about the second argument. That makes it a little bit more tricky. The first argument, though, is called data. So up here, I actually specifically said data equals diamonds, but that's kind of redundant. We could just say The first argument is there. So that's the data set that we're going to be plotting with. If we just plot this, nothing is going to show up. And nothing shows up because we've told ggplot that we want to use the diamonds data set, but we have not provided the other two critical pieces of information, which is what parts of the diamonds data set do we want to plot and how do we want to plot them, okay? So how do we add these things? We add these things in ggplot with the plus sign. So as we're going to see, we're going to be able to keep adding these different layers onto a plot to add different elements. When we get to like putting titles on it, for instance, we're going to do a plus sign and then we're going to add the titles. This is confusing because this is very similar to the pipe that we just talked about in the last video. This is very similar to thinking like, okay, we have done this to ggplot diamonds and then do this and then do that and then do that. Pipe what's on the left-hand side of the plus sign to the right-hand side of the plus sign. And that's confusing again, because that is exactly what the pipe is doing. The creator of ggplot completely agrees with that too. In a world in which the pipe existed, at the time ggplot was created, these would all be pipes, but the pipe actually didn't exist yet, and so the plus sign is here, and it's we're way too far down the road to go back and fix it. So you're going to be adding, when you're in ggplot, you're going to be adding stuff via the plus sign. You're not going to be using the pipe. And I think actually it'll throw you a informative error if you try to do just that. So let me just try. Oh no, I guess it doesn't. That is not a very helpful error. Anyways. So we're going to be using a plus sign. Okay. So we're going to be using a plus sign. What are we going to be adding to this ggplot object? We've already specified that we're going to be using the diamonds. We're going to be using this geome. And if you look at geome point, which again is one of many, many, many different types of geomes, we'll go over others in a second. The first argument here is this mapping argument, which I explicitly put up here. And this again is we're telling our which parts of diamonds are we going to use to create a scatter plot. Okay. The crucial thing here is that we don't just say mapping equals like that, like the vector of the x variable and the y variable. Instead, there's going to be this function that we're going to use inside mapping called AES, aesthetic, which is going to specifically tell, it's just like the way the syntax works. But that's going to specifically say which parts of diamonds are going to be using in these different ways. So in this case, we're using x as depth and y is price. Okay. So again, that's just doing what we've already done. Let's go back to the arrow. So there's kind of different ways we could think about how we can extend this. One thing we could think about is different geomes. We could switch up the geome here and use the same variables. We could also think about incorporating different elements of the diamonds data set into this plot. And that's what I want to do first. We can talk about different geomes in a second, but in this case, I want to show you about how you can really incorporate other aspects of diamonds into the scatter plot to make it even more powerful. So in particular, off the top, I said two things. I said first that there's these interesting cases of like these diamonds. Um, these diamonds have very different weights, but very similar prices, which is interesting. And then there's also these groupings here. So let's try to change up this plot a little bit so we can highlight those things. And we're going to do that within this aesthetic function. And again, we're thinking about here is we want to incorporate other elements of the diamonds data set into this plot. And so within AES, there's a bunch of other things we can provide other than just X and Y. X is just saying what's the horizontal variable. Y is saying what's the vertical variable. But we can also say something like color equals, and let's see if I can remember which one I did here, cut. So if we go back to diamonds, we'll see that the cut is the quality of the cut, which is ranked 1, 2, 3, 4, 5 different ways. So now, again, 3 parts going on. We're using the diamonds. What data are we using? We're using diamonds data. That hasn't changed. We're creating a scatter plot with the diamonds data. That's indicated by geom point. How is that scatter plot being created? That's the last part. And that's provided by this aesthetic mapping. And so that scatter plot is going to have the weight of the diamond on the x-axis, the price of the diamond on the vertical axis, and then the color of the points is going to be indicated by the cut variable. So this just got a whole lot more interesting. See if it loads. It's a lot of points on that. So now we've added this other aesthetic to our plot. And so now we can see that like these, so like if we think about these ones right down over here. So these are really expensive, really small, or sorry, really expensive, really lightweight diamonds, right? But they've been cut extremely well. They have a cut of ideal. These diamonds weigh a lot more, but do not have as good of a cut. And so they are basically the same price. So that kind of helps explain why we see this increased variation as carat increases. Or increased variation as price increases. Okay, so that was one part of the plot that I mentioned off the top. The other part is that you see this grouping where it's clear that these weights are not, these carat values aren't just like randomly assigned by nature. These diamonds probably weren't, well, they can't be because they've been cut, right? These are not straight out of the ground. I'm going to go out on a limb and say if these diamonds were straight out of the ground, they would have a much more straightforward distribution of their weights rather than this grouping where there's a ton of diamonds that have a weight of 1, a ton at 1.5, and a bunch at 2, relative to just under that value or just over that value. So we can kind of see that right here. You can really see it right here because there's just no dots just to the left of 1 and over $10,000. But we can increase this visually by changing the alpha of the let me say, you can change the transparency of the dots. And that's going to help in this case of overplotting. So alpha is, alpha is an aesthetic. We go to geom point. If we go to geom point, we'll see that here are the different aesthetics that we can pass via mapping equals AES to the geom point geom. We have to provide X and we have to provide Y. We can also provide color. And then there's also this alpha one, which is going to tell us the transparency of the dots. Okay? So the default is like, it's just solid. It's completely solid. And it's impossible to tell whether you have one dot over another dot. And if we wanted to change this, we could do something like, oops, is that right? Alpha equals, let's say 0.25. Let's see how that looks. Okay, so you'll see we now have much more transparent dots. And so now it's more obvious when there's a lot of dots in the same place. We could make this even clearer. We could go down to 0.1 if we wanted to. And so this highlights that, if it's just a single dot, it's pretty transparent. But if you have a bunch of dots that are overlaid on top of each other, it's going to be darker. And so this is now really emphasizing this grouping, right? So let's go back to the code though. You'll see that I didn't provide alpha within AES. Excuse me, this is tricky. This is something that took me a long time to really wrap my head around. We're providing the alpha aesthetic here. We're changing the transparency of the dots, but we aren't changing the transparency of the dots based on a variable in diamonds. Instead, we're kind of hard coding it to all be 0.1. If we wanted the transparency of the dots to vary by another variable in diamonds, let's look at color. Oh wait, we already did color, sorry. Oh no, we didn't, we did the color aesthetic, we haven't done the color of the diamonds. That's confusing. So I'm just copying this here, but now rather than providing alpha equals 0.1 like that, I'm gonna go in here and do alpha equals, actually I'm gonna do clarity, just to keep away from two colors. So now alpha is inside the mapping, inside AES, and this means that now the transparency of the dots is going to vary based on the clarity, of the diamond. But this is like, let's see if this looks. There's a lot of points, so it takes a second. This isn't really what we want though, right? This is kind of a lot to wrap your head around, because now you'll see that not only is each dot going to be a different color, but each dot is going to be a different clarity. So the clarity is going to capture, the transparency of a dot is going to capture how clear it is. The color of the dot is going to capture how good its cut is. This can be really helpful in other situations, and we can think about if there's ways we can include multiple different of these alternative aesthetics. But the point I just want to make now is that this highlights, I think, that if we want to change a feature of the plot using a variable in our data set in diamonds, we need to provide it as an aesthetic within mapping equals AES. If we want to hard code it, if we want to say that we want every single dot to have a transparency value of 0.1, then we need to provide it outside of this. Okay? So if we did it, I haven't tried this. I think this is going to go haywire though. So if you tried to do it this way, you would get this kind of weird situation where you would have this alpha value up here, which you don't really want. That doesn't make a lot of sense. So instead, we're going to provide it like this top case outside of the AES function. Cool. Okay, so let's talk about other types of geomes. There's like a staggering number of these. So let's talk about some other ones. And then I want to come back to maybe this plot. And we're going to talk about how we could make this like an even better plot and then save it. So let's go back to diamonds and let's think about things we might be interested in. I'm going to look at it. Let's say we want to see the distribution of prices. So this is called a histogram. And this is basically, we're thinking about, let's look at the number of diamonds that have a given price. And we're going to plot that visually with some bars to kind of show where are a lot of these diamond prices happening. That's not the best description of a histogram, but hopefully visually it'll be clear. So first thing we're going to provide, we're going to tell ggplot what data are we using. Then we need to tell ggplot how are we going to use our data. In this case, we're going to use it in the form of a histogram, which is geom underscore histogram. Now, which variables in diamonds are we going to use to create our histogram? In this case, I'm going to drop the mapping equals because mapping is the first argument to geom histogram and geom point. We don't actually have to say mapping equals. We can just say AES and then provide the necessary data. So I can never remember. I do that dplyr stuff that we did in the last video day in, day out. I have it all memorized. I do not use ggplot every single day. So I have to look at a lot of these help documents. And I'm justifying not more fully preparing for these videos with the fact that I think it is somewhat helpful to see how we troubleshoot and remember things. So I did the question mark geom histogram, and in particular what I'm looking for is this really helpful part of all of these geoms, which is which aesthetics it uses. So here, and I got to, now I'm on a geom bar aesthetic, which is like a bar plot. But the geom histogram page told me that they use the same aesthetics. And I always have to look at this because I always need to know what is necessary. Which values in AES are necessary to create a histogram. Although I don't know if that's right. This might be a bad one because I think it just needs an X. Let's see. X equals, usually what I said is going to be helpful, but I think in this case, we just need to provide this. Okay. So bad example, but there we go. Okay. So this code, same at the macro level, three parts of this, right? Providing a data set to ggplot. We're telling ggplot how are we going to use this data. We're going to use it in the form of a histogram. What parts of diamonds are we going to use to create the histogram? The price variable. We just need to provide price. So you'll see this warning popped up here. This warning popped up. That's because the data is currently, to create a histogram, you have to like lump stuff together. So right now, each of these bars, I think they put 30? Not exactly sure what each of those bar means it works. But let's make them a little, let's change them up a little bit so we can. So it's the number of like ways that we're kind of splitting up the price variable. So let's just do bins equals 50. So here we can see on the x-axis is what we provided. We provided the price, right? Provided the price of each diamond. And then this up here is telling us how many diamonds fall within each bin. So the first time, okay, here's what the bins do. The first time we took all of our data, took all of the diamonds, and we separated them into 30 different bins. Boop, 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 boop. And then we counted the number of diamonds that fall within each of those bins. Now we have 50 bins, and we're counting the number of diamonds that fall within each of those bins. So what we see here is what's the distribution of the price of these diamonds? A lot of diamonds have a price around here. Very few diamonds are really expensive. Okay. So that's a histogram. So again, a different way of plotting some data. Let's think about a different one. Let's use some of our dplyr skills from the last one. Let's look at let's plot the mean diamonds. Let's look at the average price for each cut. So let's think about how to do this with our pipe. We're going to start with diamonds. We want the mean by, what did I say, cut? We want the mean by cut. We're really just interested in the summary information here. So we're going to summarize the data. And we're going to say, I'm going to call cut mean equals the mean price. So that comes out just like this. So we have each cut, and we have the mean price for each cut. So you could actually pipe this right into ggplot. Just in case you're curious, you could go something like this and then do ggplot and then do your geom from there. But let's not do that and just call our data plot1. And then let's do our ggplot formula. So providing our data, what's our data? It's going to be plot1. what are we doing next? Next, we're telling R how we're going to be using this data in plot one. And in particular, we're going to be using a bar chart to kind of compare these different values. And I can never keep these straight. There's two different types of geomes that look like bar charts in ggplot. The first one, geome bar, makes the height of the bar proportional to the number of cases in each group. That's kind of like a histogram. If you want the heights of the bars to represent values, use geome col. That's what we want because we want the height of the value to be the mean price by cut. Okay? So we're going to use geome col, AES. Let's look at what aesthetics are necessary. It should just be X and Y. Yep. X equals what's going to be on the horizontal axis. The horizontal axis is going to contain the different cuts. Is it fair? Is it good? Is it very good? So, on the y-axis, we want to plot the mean price by cut, which is cut. And there we go. So in this case, this is not tremendously interesting, but you will see it's actually kind of interesting. I know this is all like, it's not exactly social science data, but it is kind of interesting to think about this stuff. So I was kind of expecting the average ideal price to be higher, but it seems that average ideal is actually really low. And my guess off the top of my head is that that means that there's a lot of really small diamonds that have ideal cuts that probably aren't worth it. That's my guess. But you will see that we have done this bar chart. So we've gone over what, 3 different geomes? Geome col, geome histogram, and geome point. There are, as I've said, a ton of different ways to do this, a ton of different types of geomes, and I can rarely keep them all straight. And one of my favorite things to do, which I'll put this in the R thing, is when I want to figure out what geome I want to use, I love going to this website. So it looks a little wonky, but if you type it out, you should be able to get there. I think if you just do this, you should get there too. So I worked at the Urban Institute, social policy think tank, before grad school, and they do a lot of very cool quantitative work, and have a lot of awesome resources for those of us who use R. And one of my favorite ones, is their section on data viz. And basically what they have done here is provided a ridiculous number of different types of plots that vary on, that show off like just about every single geome you could want to use. So like this is kind of something that we've done where we're creating geome points, and then we're grouping the data by different colors. That's kind of what we did with the diamonds. But there's also just a ton of different examples in here. You'll see they also are using the diamonds data set. And if you want to see the code that produced each of these, you can click up on the code button and you can see the code and apply it to your specific case. So I think this is an amazing resource. Whenever I have a bunch of data and I want to think about different ways to plot it, this is actually one of the first places I look. So I don't want to spend this time just talking about a bunch of different geomes, because I don't think that's necessarily the most helpful thing. Instead, what I want to do is I want to talk about what else you need to do to kind of create like a production ready, a publishable, whatever that means for you, plot. So let's go back up to this one because I think this one's one of the nice, is a fun one that we did. And let's talk about what else is necessary to kind of make this a nice plot. So a couple things I think are crucial. First off, you need a title and you need informative captions, an informative thing on the x-axis and an informative thing on the y-axis. So let's complicate this a little bit. And let's do price in thousands of dollars now. You'll see how easy it was to do that. I didn't have to use mutate. I could just do divided by 1,000 in the plot, which is really cool. And so now our y variable is going to be price. Our y caption is going to be price divided by 1,000. So let's add a title and let's change our y caption, the caption on our y-axis. I think our x-axis is fine. I think caret is fine. So how are we going to do that? We're going to do that by adding another layer to this plot. So we're going to do the plus sign. And then there's this function called labs, where we can add all of our different captions in one place. So I'm going to give this a title. Naming these things is the hardest part. I'm going to say this is the price of diamonds by weight and cut. Let's do something like that. Cool. So now we have, let me take this zoom thing. Here we go. So now we have the title. Now let's change this Y caption so that it makes a little bit more sense. Y equals, let's say, price thousands of dollars. Cool. This is looking a lot better now. You could look at this, and know what's going on without having watched this video for the last 30 minutes, right? Like it's, you based on the title, based on our captions, this has kind of made sense. You might have to Google what caret is, but don't worry. Okay. A couple other things. This is kind of because I'm like super particular about this, is I think it's really obvious. I think there's a lot you can do to make these better, that it involves going beyond like the basic themes here. The basic, by theme, I mean the basic font, the basic background, this like gray background. I think it looks fine, but I think when you've been doing this a while, you see the defaults a lot, and it's nice to kind of spruce it up. And there's these different built-in ones you can do, like theme. Let's just see what this looks like. Ooh, I don't like that at all. Let's try theme underscore light. I'm just kind of playing around with it. You can endlessly customize all of these features. These axis lines, the background, the color of the background. You can do that as much as you want using the theme function. So here we've provided this specific theme underscore light. We've added that to our plot, but you could also do plus theme and then change everything to your heart's desire. Because I'm really dorky, I actually have my own default theme, which if you search my name on GitHub, which is like this, like, think Dropbox for programmers, you can see my default theme and you can load it. It's basically actually exactly what Urban's is. Let's see if I can find that. It looks a lot like this. I think this looks really nice and really clean. I just changed the font so it matches the word, like the defaults for the word processor I usually use. So that's just a long-winded way to say I encourage you to change the defaults in your plots. Depending on how much you care, you can go in and change everything yourself, or you can use these built-in themes like theme light. There's a theme, I think, minimal, that looks fine. This is probably my favorite. I think this looks really good. So you can also change the colors. I don't want to go over that now because that takes a little bit longer. But you can change the colors here. Anything you see here is changeable. One thing I do want to add here is I do want to go over how we could change the kind of like the labels on our axes. So kind of another like stylistic thing that I like is I don't like to have data that goes above my last label here. So I personally would prefer to have a 20 labeled up here so I could get a little bit more perspective on where these points fall. So let's do that. That's the wrong one. So how do we change things like labels, ticks, breaks, whatever you want to call them? You're going to do that with this series of functions that you're going to add to your plot called scales. And in particular, what do we want to change? We want to change the scale for the y-axis. And our y variable, price, is a continuous variable. So if you saw that there's a ton of different scales for all of these possible aesthetics up here. Which one am I interested in? I'm interested in the one for y. And then I need to know what type of variable my y is. Usually there's a lot over here. Usually these are going to be one of two things, or it's either going to be continuous or it's going to be discrete. An instance of a discrete variable would be in that example above where we did the mean price by cut. The cuts on the horizontal axis would be discrete. Well, let's use this one. So if we want to change this, we need to first change the limits of our plot. And that's probably easier to just show what I mean with an example. So this is going to look really wonky, I think. So you'll see that I changed how high up the labels are going to go. This looks ridiculous, but this is just to say that sometimes if you want to add labels further on, you might have to change the limit like that. So I'm going to set the limit from 0 to 20 so that I know that I'm going to get that 20 point. And then I'm going to set breaks equal to, so I want 0, 0, 5, 10, 15, 20. A shorthand way to do that is this sequence function. I'm going from 0 to 20 by 5. This is just base R. I can just run this on its own. It's going to look like that. So let's see if this works. Cool. So we've added this 20 up here that wasn't there before. I think changing these axes is tricky because there's different things going on. You have to deal with the limits at some points, and you also have to change the brakes. There's also another thing here that if you want so right now our brakes represent points in the data, but this is going to look kind of weird. But if we wanted to actually change what each brake said, we would have to use labels. So we could do something like A, B, C, D. And again, this isn't going to make a lot of sense in this case, but I just want to show you that it is out there. Okay, so now we have A, B, C, D, and E on our vertical axis. Now, obviously, this doesn't make any sense in this case, but there might be other points in time where you want something else than what's in the data on your axis. And just to show you how this could how you can really just change this to your heart's desire, you could do something like, let's only look at 0 and 20, and let's call point 0 on the y-axis A and point 20 B. Now we're just going to have 2 points. We're going to have an A down here. It's called A B up here. So again, that doesn't make a lot of sense, but just to show you how you can do that. Okay, so we got this. Cool. Last thing you want to do. Right now you have a plot. You want to get this out of R and in like a PDF so that you could email it to somebody or put it in a paper, whatever. The key is you want to do this in a way that preserves the quality of the image. The quality of the image is not preserved if you just take a screenshot of it. Not the best idea. Instead, we want to specifically save this. So this is going to involve like your project, your working directory, in the same way as reading in data. When you write out data, it's going to go to where your current directory is, which if you're working in a project, which I hope you are, is going to be where that project is located. So how are we going to do this? We're going to use this function called ggsave. We're going to provide it the path, or in this case, let's just call it the name of the plot. So we're going to save my first plot.pdf to the urop video 2 folder. The default is to save the last plot you created, but you could also be more specific here and call this plot 1, save it as an object, and then include it like that. Okay. And last thing, so if you look at ggsave, you can get away with just providing with not providing heights and widths. But I usually like to, because the defaults are based on the size of this window. So like if this is really big, it's going to provide a different size, which is kind of weird. So I usually like to provide them. So let's say I want the height to be 5 and the width. So you kind of have to play around with this a little bit. So width equals 6, units equals inches, What? Save. Oh, I remember. Plot one was a data frame, and I hadn't reassigned plot one to be the plot. My bad. Okay. So now if we go to our folder, we'll see that we have saved our plot in URUP video 2. Sweet. So now we have this as a PDF that we can do stuff to, etc. And it's also, because it's a PDF, it's going to be really high quality, even when you're zoomed in. It's going to be great. Let's see. I think I'm just about to time. Let me see if there's anything else I wanted to. In addition to the urban site, I highly encourage you to check out chapter 3 of the awesome book R for Data Science. This is available online for free, and is a very accessible intro into ggplot that goes into a lot of other stuff that we didn't cover here, including other aesthetics, like rather than each dot being a different color, you could have each dot be a different shape with the shape aesthetic. And let's see if they do other stuff in here that we didn't do. You can also facet wrap data. I don't want to talk about this right now, because that might take us over time. But facet wrapping allows you to create the same plot multiple times for each subset of your data. So let's see if I can do this real quick. So let's take our plot up here. I'm going to cut out that. So let's say we want to do this for different colors of our diamond. So not the color aesthetic, but different colors of our diamond. And we actually wanted to like create this plot for different data sets. So imagine taking the data, filtering it down to just the diamonds where color equals D, the best, and then making this plot. And then filtering the data to all of the diamonds where color equals J, the worst. And you want to create all these plots and put them next to each other. So that seems like a really big task that involves a lot of filtering and then creating a new plot and then figuring out a way to like put all these plots next to one another. But that you can also really cleanly use a facet underscore wrap, and then you can wrap it by a discrete variable like color to create all these plots next to one another, which can be in some cases really, really cool. So you'll see that, again, I think D was said was be the best color and J was the worst. And this is actually, again, this is data, doesn't really matter, but it's kind of interesting. So for the J variables, or for the J diamonds, the weight has to be higher to get the same price relative to the diamonds with the worst color. Did I get that right? No. Yeah. So these ones have a worse color, and so you need more weight to get to the same price up here for a diamond that weighs the same. because these ones have a better color in them. So there's just like interesting parts about this. But you could see how this could be really helpful in some other scenarios. So just as another addition in here that could be helpful. Okay, I'm going to call it there. Thank you very much. Again, the urban site and the R for Data Science site are amazing resources. ggplot has also been like so extensively used and documented that there's going to be a lot of really helpful answers in different places on the internet to probably a lot of questions if you're working on stuff. So I encourage you, if you are looking for help on a specific thing, include at the beginning of your Google search R ggplot and then try to formulate your question. So you make sure that you just get the answers for ggplot. Okay, cool. Thank you very much. And I will see you all in the next video. Once I figure out how